arithmetic sequences is what we're going to talk about more specifically now. So, excuse me. With an arithmetic sequence, you will always have what's called a common difference. CD, if you will. Yes, we will write that as CD oftentimes, common difference. And a common difference means you either added, or you could say subtracted, or added a negative is another way to think of it, to get your next term, okay? That's your common difference. That's how an arithmetic sequence will work. You're always adding and subtracting. You are not multiplying and dividing, okay? Arithmetic sequences, add and subtract. So if I said that I had 10, 15, 20, 25, and 30, and I said, what's the common difference? What would it be? Plus 5, right? We're adding 5. Plus 5, plus 5, plus 5, plus 5. Okay, that's our common difference. If you're struggling to figure out how to find your common difference, you can always do the second term minus the first term. Okay, if you do second term minus first term and you get a positive, that means you're adding that number. If you get a negative, it means you're either subtracting that number or you need to say we're adding a negative, okay? But as long as that number stays constant, whatever so second minus first, third minus second, fourth minus third, as long as that number is constant, that is your common difference, okay? So first thing we're going to do is ask the question, example 1, is it an arithmetic sequence? Okay, so I'm going to give you a sequence. You tell me, is this an arithmetic sequence based on what we know? 2, 5, 8, 11, ... So the sequence keeps going. Is this an arithmetic sequence?
Yes.
Why?
Because it's plus 3.
It is plus 3 every time. Plus 3, plus 3, plus 3. Now, if it had been plus 3, plus 2, plus 3, that's not an arithmetic sequence. It has to be a constant number that you are adding each time. So we would say yes, and our common difference, is 3. Okay. How about this one? 1, 4, 9, 16, 25. Common difference? Sorry, arithmetic. Is that arithmetic? No. If you look, arithmetic sequences have to be adding the same thing. That's plus 3, that's plus 5, that's plus 7. That is not the same thing. You're actually multiplying here. Do you recognize those numbers? You should. Perfect squares, right. Okay, formulas. There are a lot of formulas in this chapter, but here's the beautiful thing. We give you every one of them on your test and your quiz. So you do not need to memorize these formulas, okay? Yes, I believe so. I should double check that with Mrs. Price, but we would not make you memorize them if we didn't during the chapter. So yeah, you should have them for the final. Okay, so just keep that in mind. Don't spend time trying to memorize these. Just put them in front of you while you're doing the work, okay? While you're doing your homework, have them in front of you so they're very accessible, okay? Girls, let's do math. Okay. So we are going to talk a recursive formula. Now, granted, this is for arithmetic sequences, okay? You'll learn different ones for geometric sequence, okay? And we're going to do an explicit formula for arithmetic sequences. So here is the formula, okay? For recursive, the formula will be this. A of 1 equals your given value of your first term. And then A sub n will always be A sub n minus 1, right? Like we just said before, plus what we call D, which is our common difference. okay? So this number is your common difference. And we just did this in the last lesson. So this should not be a new concept to you. It's just that now we're giving it a form, okay? We're giving it a variable in that place. So that is the recursive formula. The explicit formula, also for arithmetic sequences, is this. You will have a sub n, and this is the one that you did in Algebra 1A, so you'll have to see if you remember this, equals a sub 1 plus n minus 1 times d. And again, this is the common difference. A sub 1 is your first term. Okay? So you'll take that formula and be able to plug numbers into it, right? With explicit formula, we can say, what's the 15th term? We'll plug in a 15 right there. All right? Okay, so let's try this out. Example number 2. Let's say you have this set of numbers, 7, 10, 13, 16, ... For the first thing, we're going to say write a recursive formula. Okay, write a recursive. So recursive always starts with what? A sub 1, right? Always with your first term. So the recursive formula would say a sub 1 equals 7. First term is 7. Okay? The second part says a of n equals a sub n minus 1 every time. And then what goes behind that? Plus 3, the common difference, right? This is plus 3, plus 3, plus 3. So we're going to put a plus 3 here. So when they ask you for the recursive, that's what you give. Okay? The second part, they're going to say write the explicit formula. Okay, and explicit is right here. We're going to say a sub n equals what? 7, first term, plus n minus 1 times what? Times 3. Okay, now here's the deal with this. We want it simplified. This is so simplifiable, right? We just need to distribute this. So a sub n equals 7 plus 3n minus 3, and then simplify here. A sub n equals 3n plus 4. So your explicit formula, as simplified as we can make it, is that. Okay? Questions on that? All right, let's try another one. You have 213, 201, 189, and 177. Okay, ... keeps going. So the recursive formula. What do you always do first? A sub 1 is 213, right? First term. And then a sub n is always going to be a sub n minus 1. And then what? Minus 12. If you look here to here, right? And again, if you can't see it, you always take the second term minus the first term. When you subtract those, you get negative 12, right? So that means we're subtracting 12 each time. So take this term minus this term, or this term minus this term, or this term minus that term, okay? Always the term behind it minus the term in front of it. We get a minus 12, so a sub n minus 1 minus 12.
So if it asks for the recursive formula, or like the one like that, it's always going to have
both of these parts.
But we're gonna have like a pattern.
It will always have a sub n equals a sub n minus 1, and then whatever your common difference is, plus something or minus
So
something.
there's always gonna be a common difference.
Yes. Mhm. All right. How about explicit? A sub n equals the first term, 213, plus, this will always be n minus 1, then what? Times negative 12, right? Not minus 12, but multiplying by negative 12. Okay, so that's our setup. If we distribute this, we get 213. That would actually be minus now, minus 12n plus 12. Okay, simplify once more. You get a sub n equals negative 12n. You can put the whole number first, the constant first. I don't care, but I always like to put the coefficient to your n first. And then this would be plus 225. So this would be your explicit. Okay. Now, question for you. If they said write the recursive, write the explicit, go from there. Put your phone away. If from that they say, okay, now find the 25th term, which formula are you going to use? Explicit. Okay. If they're asking you for a term that is not like 2 past the one you already have, don't use recursive. Use the explicit. So if we want the 25th term, we're going to take this and say a of 25 equals negative 12 times 25 plus 225. So your 25th term comes out to negative 75. Okay, you could do recursive, but man, that is a just big waste of your time when you know an explicit formula, right? But you can, it's not wrong. I just wouldn't. Questions on that? Okay, last thing. Last thing we're going to talk about is called an arithmetic mean. What's a mean? It's an average, okay? Essentially, we are finding an average, a mean. So you're going to take the sum of two numbers, and if it's two numbers, what do you divide by? Two, right? To take an average, you take the sum of the two numbers you have, divide by 2, and you'll get your arithmetic mean. So, for example, number 4 here, they're going to tell you that this is an arithmetic sequence, okay? It has to be told that it's an arithmetic sequence, otherwise you can't use this rule. If this is an arithmetic sequence and I give you 84 something 110, okay? The way we're going to find the arithmetic mean is we're going to take 84 and 110 as our two numbers and average them. We're going to find the average because then we'd be adding the same amount each time, okay? So we are going to do 84 plus 110 and divide by 2. 84 plus 110 divided by 2, or 194 divided by 2 is 97. So the number that goes in place here should be 97. Okay, and you could always double check that. Subtract 110 minus 97, 97 minus 84. It should be the same value between the two. Each of those jumps up by 13. Okay? Okay, but what if it gets a little bit fancier? Still not terribly fancy, but we put a few more blanks in. Let's say you have 12, a number, a number, a number, and then 48. Can you figure out how you would find the arithmetic mean? Right, you're going to start by finding the middle number, right? The average of these two is this one. So if you start with 12 plus 48 and divide by 2, I get 60 over 2, or 30. So this one is 30. Now how do you find this one? 12 and 30 averaged will give you that one, okay? So now you're going to go 12 plus 30, and cut it in half. Let's just do that down here. I'm running out of space. 12 plus 30 divided by 2, or 42 divided by 2, is 21. So this one will be 21. And then for your last one, you're going to do these two. 30 plus 48 divided by 2. So 78 divided by 2 is 39.